Hi, welcome to Wise Guys. Electric potential energy and potential. In this video, we're looking for the electric potential energy U for this situation, which is there are three charges put on the vertices of an equilateral triangle, and each side is 12.5 meter. This is each side is 12.5 meter, 12.5 meter, 12.5 meter. The Q1 is positive charge 8 microcoulomb. Q2 and Q3 both are negative 9 microcoulomb. The formula, as we know, is point charge, the electric field potential energy is U equals K, Q, and a small q, that means both charge, different charge, and the R is between these two charges. Using this formula applied into this question, there are three pairs of charges, because Q1 and Q2, we write Q1 with Q2 is K Q1 Q2, and R is between 1 and 2. And also we can write Q1 and 3, Q1 and Q3, which is K Q1 and Q3 over R13. The other one is 2 and 3, so that's why Q2 and 3 equals K Q2 and Q3 R23. Because electric potential energy is a scalar, that means describe the capacity of doing work. For example, you first bring Q2, negative Q2 at this place. After Q2 has been set up, when you move Q1 from infinite, or we can say from outside the electric field into this electric field, which is produced by Q2, negative Q2, so there is an electric field force between Q1 and Q2. Q2 is negative charge, Q1 is positive charge. That's why the electric field force is they attract each other. So when you bring Q1 from outside to the field, they have attraction. That's why this situation is electric field force doing work, right? Because the direction of moving and the direction of electric field force same. That's why is electric field force doing work. Once set up, there's still attraction, but Q2 is fixed and cannot be moved, but Q1 we also want to fix it. That's this situation, and they no more moving. Okay, even they have electric force, attraction force between Q1 and Q2, because both are fixed, so they cannot move. So that's why this situation, electric field doing work, that's why they have electric potential energy, which is used this way. Similarity, we can say, with Q1 and Q3, the energy is this, and Q2 with Q3, both negative. Right? When you bring Q3, negative Q3 from outside, from infinite, or we can say, into the field, these two both negative charge, the force between these two are repulsive. But you want to bring inside, you need to use external force, move Q3 to this place. So that situation is external force doing work. So what is the total electric potential energy with these three charges fixed like this way? So we calculate each of them. The other thing before calculation, we need to be careful because electric potential energy is scalar. So that's why no direction, only magnitude. Only magnitude, but we still have positive and negative. The reason is positive or negative just describe if it is electric field doing work, field force doing work, or external force doing work. So that's why we need using positive charge or negative charge when we do calculation. Okay, that's why we can do this one. We can do U23, which is with Q2 and Q3. The unit of electric field potential energy is joules. So that's why this one is joules. K is Coulomb's constant, which is 9 times 10 to the 9 exponent. And the Q2 is negative 9 times 10 to the negative 6 coulomb, because we need to convert microcoulomb to coulombs, and multiply Q3 also negative 9 multiply 10 to the negative 6 coulomb. Divide the distance between 2 and 3, which is 12.5 meters. Right, this one. This is a coulomb, this is a coulomb, right? And as a result, negative multiplied negative is called positive. The number is 5.83 times 10 to the negative 2 joules. And then we can calculate Q1, 2, and 1, 3, because Q1, Q2 equal Q3. That's why Q1 times Q2 and the Q1 times Q3, and it will be same answer, and also R same. So that's why Q1 2 equals Q1 3, both equals 9 times 10 to the 9 exponent, which is Coulomb's constant, and multiply both charge is one is 8 microcoulomb, which is 10 to the 6, because Q1 is positive and the Q2 is negative. So negative 9 times 10 to the negative 6 and divided by 12.5. So the answer is positive multiplied negative equals negative 5.18 times 10 to the negative 2 joules. So after we done 3 pairs, then we can add them together. The reason is they are scalar, it's not vector. So we don't need to do vector addition, we just add 3 of them. So the total U, okay, I need to go to this page. Total U equals U23 plus U12 plus U13, which give us U equals is U23 is 5.83 times 10 to the negative 2 joules, which is positive. This one is positive, and plus 1, 2, and 1, 3. This is negative 5.18 multiplied 10 to the negative 2 joules plus another negative 5.18 times 10 to the negative 2. As a result, the U equal give us final answer is we add these three because there's positive, both, and negative. Finally, we got the answer is negative, which is negative 4.53 times 10 to the negative 2 joules. The negative means this one, that means this is an electric field force doing work. So that means we need 4.53 times 10 to the negative 2 joules energy from external force to separate these three charges. Now they brought together. If we want to separate them again, so we need 4.53 times 10 to the negative 2 joules of work and from external force. Okay, this means electric force doing work. So we need 4.53 times 10 to the negative 2 joules of energy is needed from external force to separate three charges. Okay, this one is presented by Wise Guys. Thank you.